My name's Adam Moore. I work at Yahoo. I work on the YUI team. And I was going to talk about something that's been going on for the last about 2 or 3 weeks. Dave Glass, many of you are probably familiar with him. He's an engineer on the YUI team, and he's been experimenting with running YUI on the server side, specifically YUI 3. And really, he made a lot of progress in a short amount of time. In fact, if you're thinking I'm talking about events today, I changed it at the last minute because this was a lot more interesting, a lot more topical for today. So, we chose Node.js. I think everyone knows what it is. You saw Ryan's presentation yesterday. It was basically, it's fast, and it's a JavaScript server-side process. We're not looking at Node.js as being the only thing we're going to try this on, but this is what we've done so far. So we wanted to try this because we think it is time to basically take advantage of all the code that we've been writing on the client, the APIs that we have in YUI. People are writing more complicated applications that can be translated to the server, and hopefully we can do some really cool things. And one of the things I want to talk about in particular is progressive enhancement, what it means to be able to take the same code that we're currently generating controls with on the client and moving it to the server as part of our progressive enhancement strategy. So YUI 3, it's pretty new. Some of you might be familiar with YUI 2. One of the fundamental differences is that it's very modular. It has a module format that's similar to the CommonJS module format. The strategy for loading YUI is a small seed file, 7K seed file, which knows how to bootstrap the YUI loader and complete itself, whatever dependencies that you need. And one thing about the core of the library, it's not just about manipulating DOM, and that's important because when we talk about Node.js, we're talking about a JavaScript runtime. We're not talking about a full browser implementation. So what can we do with just the core? We can do I/O. We do data communication. We have an abstraction for managing our data sets and communicating with remote resources and getting that data in JSON format or other ways. We have a custom event system and custom attribute system. If you look over at Node.js, there's a modules directory that has a lot of these sorts of things that sit on top of Node.js today. But these are different APIs. They may be good. We already have code that's written with all this stuff that we can actually use it today on the server side with the way that Node, with YUI, the way that YUI works on Node today. We also have a lightweight templating engine. It's kind of related to the last talk if you were here. The idea is that the same thing that we might use to generate strings can be used on the client server situationally. So just a little bit about how we made it work. First of all, as of YUI 3.1.0, we are exporting the YUI object. We're basically complying with the specs so that any implementation that's going against the CommonJS spec, it should just work. At least the core part of the library. The rest of our modules use our module format. YUI knows how to load those modules, but we don't have explicit exports for each one of those modules. So once we did it, it pretty much worked, but we didn't really know what it was doing. So what we did is we configured YUI to use a Node.js way of actually outputting whatever log messages that are coming out of the YUI system. YUI has a built-in logger that will log to the browser console, but in this case we can pass this this configuration attribute to make it so that we can see what it's doing. And we can do a simple program. I know it's boring, but this is how we get YUI running. There's a project called nodejs-YUI3, and that project's available on GitHub under Dave Glass's account. And by the way, you can both Node.js and YUI3 can supports chaining, so you can chain it if you like that kind of thing. And that first line is actually not required. It just makes it more simple to execute the program. So this program can be written in one line. But then it works, does what you expect it to if we execute it. And so that's cool, but it doesn't really do anything with the rest of the library. So the next part was to get the loader to work. And so the way the loader works in a browser is it goes out, fetches remote, well, it calculates the dependencies, fetches remote resources, and inserts script nodes into the document, and then sets everything up. So all we had to do is replace the transport that YUI normally uses to something that is more, that uses nodes, either remote HTTP request or local file reads to get these resources instead of trying to insert script nodes. At that point, everything in our system that relies on script node inserts just worked. So loading these resources, also things like JSONP where we're fetching remote data and processing that data. So we can test that out. This was the first little simple test that says, okay, we're going to get YUI. We're going to have it fetch the custom event system and all the dependencies that it requires. We're going to test out the custom event system. And now we see, basically this is the output of it. And, it analyzes the dependencies. It gets the loader. It fetches all the individual components. In this case, on the local file system, it could get it remotely as well. Hooks everything up, and then finally executes that custom event. So it works fine, and that's cool. Something more sophisticated. So YUI knows how to load itself, but it also knows how to load YUI3 gallery modules. And if you don't know about the gallery, basically, you can submit your code onto our gallery and request to have it on the CDN it has to be released under the same license that YUI is and all this. But we will put it on the Yahoo CDN, and then intrinsically, YUI3 knows how to load that. And so in this case, I'm actually going to request a YUI3 gallery module for YQL and JSON. So it's going to go out, it's going to get YQL from the gallery, so from the Yahoo CDN, analyze its dependencies along with the JSON dependencies, do another combo URL to get all those, or actually in this case, I think I'm getting them, I'm configured to get it locally, yeah. And then finally, I can do a YQL query, and I should get, the results I'm expecting. In this case, I'm querying my GitHub user data. And I cut out all the boilerplate, but if I ran this, it would look like this. So it goes out, it's going to fetch, it's going to go and do all that dependency processing like I was talking about, finally execute that query. So on my machine right here, running Node.js, I've gotten remote data, local data for the library, put it all together, executed a YQL query, which in turn used the new script transport that I replaced, and executed that query. I got everything back, and it works fine. So pretty pleased with that. But that's a good start. We had some other ideas. YUI, like I said, YUI knows how to load itself. So why not have YUI load itself from the server. So now let's talk about putting YUI behind a web server, or actually exposing it as a web server, and using the built-in loader, have it emit script and for YUI. So in this case, what I've got here is a loader service that actually will provide combo handling locally. All I'm doing is I'm configuring YUI to look for the resources in a different location, which in this case, this is a working web server on Dave Glass's test machine, and it should still be working. So I execute that code. It looks like this. I pointed at his combo server. This is drag and drop. It works. If we look at the head of the document, you can maybe see, if I can fit it, that this is actually one combo URL or combo handled script that was served from his machine. So that's cool. Taking it a step further, because YUI knows about the dependencies that it requires, we can take it one step further and say, when I request that YUI script tag, I can also fill in the dependency trees that I know I need up front. So in this case, I'm passing in module names that are YUI module names, drag and drop and IO. And it's on the server side, it's going to analyze all the dependencies, give you one combo URL for everything, and now I can immediately access that. There'll be no further HTTP requests if I don't need anything else. One step further, Quick YUI is a little extra service on top of it. It says, okay, well, let's make it as easy as possible to use YUI with this combo service. So I need these components. I'll go ahead and get all these components, combo, handle them, deliver them, and I'll also create a global Y variable, create that instance for you. Now you can get rid of that boilerplate code that wraps the actual application, trying to reduce the barrier entry to getting your application running. So all that works, great. It's working right now. So that's same deal. By the way, YUI, that loader service is still on the client side here. So once I do that initial request and get that payload, I can always add more stuff that isn't already on the page. And the same syntax you use to set up your instance can be used later. In this case, I can ask for slider. The syntax for YUI I use is, okay, here's the component. Give me a function to execute at the end of it. So whether or not I already have the component available or I have to fetch it so it's asynchronous, my code can run right then, and it's all good. By the way, we can also combine custom resources depending on your configuration. There are a lot of configurations for you to serve your own components from your server, or like I was talking about with the gallery. If you submit it to gallery, get it on the CDN, intrinsically it will know how to pull those resources. So let me back up a second. I know that I've heard that there's a few people that prefer jQuery. So I thought I'd try to see what happens this morning if to get jQuery in here. So I ran this, so I put this together. So this is actually how you can configure those external resources. This is one way, and I'm just saying that I have a jQuery module that's located here. Then I can use it, and it will pull it and then try to execute that code. And it's actually, if I run that, It fails. It fails. It's not surprising. It's looking for a window. YUI would have failed that way at one point in time as well. Before I mentioned that YUI isn't all about the DOM, but it is a lot about the DOM. So is jQuery and these other libraries. And so the next step after all this is like, how cool would it be if we could have some kind of DOM on the server side along with Node.js and be able to use more components from our library. So Dave got on the case. I think that was after the first 2 days, everything I did here. The next 2 days, I think he got the rest of it done. But he put together a couple of projects that are out there, JS-dom. Both of these are available on GitHub. JS-dom, he worked with the author of that one to get it to work the way he needed it to work. And HTML parser, he kind of hacked that, forked it and hacked it a little bit. We needed it for inner HTML. The JS-dom provides full DOM level 1 support. And these are generic JavaScript implementations for developing a fake DOM. And it works. All of our DOM-related components can run under this. Things like selector API, our node wrapper around around HTML elements, DOM creation, manipulation, styles. All these things actually work. Our test suites pass. It looks a little bit like this. Basically this server that we have now, this HTML service, can actually create individual requests with their own document, and we can start working with the DOM after we have all that boilerplate set up. And it's running right now on that test server. You can take a look. Calendar control, not that interesting by itself, but this is a control that is in YUI 2. So first of all, we're pulling that combo loader is also pulling YUI 2 resources via the 2 and 3 project that we put up with 3.10. So this is rendering the HTML for this calendar control. Exactly the same HTML that would be rendered if you ran this code on the client. But the difference is now each time I do something here, I'm clicking pieces of the calendar control. Each time it is going back to the server. And in fact, if you look at the source, we're not delivering any script at all. It's all just HTML and CSS. Well, what's cool about this is that this can be a part of our strategy for progressive enhancement. You know what progressive enhancement is? Basically, your content should be available to everybody, all devices, browser, new browser, old browser, assistive technology, devices, and we can use CSS if we have it to make it pretty and JS to make it work more fancy if we want. But the core thing is that everybody can get that content. And what we just saw was that this calendar control is the exact code that rendered from the server as we would render on the client. That calendar control can also render itself from pre-existing markup in order to support progressive enhancement. So basically, that calendar control has all the engineering you need in it to get progressive enhancement out of the box. You don't have to build a server-side application that generates markup in PHP or whatever it is for the core markup that's going to be enhanced by that JavaScript code. It's the same JavaScript code on both sides. So here's another example. It's not very pretty, but it actually illustrates another aspect of it that's cool. So this is a template system. We have a multi-pane view that we want to render. Well, first thing that we might do is pull that entire HTML content down. But subsequent requests, we don't need all the Chrome around it. We don't need anything but the new content generated. So we can situationally say, okay, I just want that content area. Or in another situation, we might not need any HTML rendering on the server at all. Maybe we just want the data. And we can get that with the same code and just a little bit of a switch in there. We can have that same code output 3 different outputs. And what does that get us? Well, in this third situation, this is where I say, okay, I have a client component that knows how to render itself. This is the enhanced experience. Each click is going to ask for the JSON data so I can rebuild the page on the client. I can generate the HTML. But what if I have, I want to deliver it to a mobile device? Having all that script on that client is expensive, val time, execution time. Maybe I just want to deliver a small JavaScript piece that knows how to ask for just a content area each time. And then, of course, that first example, this one here, when it renders the entire HTML piece, is the degraded experience. It's the one that's available to anyone. So three different responses, the same code, a bunch of tools in there, built in, already engineered for you to help you do progressive enhancement without extra engineering costs. And that's a big deal. If you watch the presentation, Jen's presentation yesterday, you see all the sites that don't do progressive enhancement at all, because it's not easy, but you need to do it. So that's why I think this is cool. There's other things you might do with this. You can to have the DOM available, we can maybe do some fast testing along with my build. It's not a replacement for browser testing, but you can actually do a lot with the utility layer that doesn't actually do any DOM manipulation. And I could even smoke test a DOM, DOM manipulation, because we do have a complete DOM. We can do a lot of stuff there. We could hack it. We can provide any kind of document we want. So we could actually try to emulate things we know that are broken in IE, just to smoke test it before we do the full browser testing. Also, validation code is an obvious one. We have to validate form fields on the client and server. Writing that code once is better. And so YUI 3, it got working under Node really pretty easily. We're excited about being able to run some of the code that we already have running on the client on the server. Just like presentation before, and I've heard many times, we're a little bit lazy. We don't want to have to write the same thing twice in different languages. And the DOM work that's gone on so far has really, actually surprising too how it performs pretty well, even though it's rendered in script rather than in C space. But there's other people that are working on projects where they might build the same sort of functionality in libxml or Xerces, or maybe even try to get a WebKit implementation hooked up to it to make it faster. But today it works really well, and if you're interested in this stuff at all, I talked about the gallery. I mean, try it out, submit it to a gallery, be part of that community, help us out. It's there. We'll serve it. We'll serve it from our CDN for free. And that's all I have. Are there any questions?
Is MIT BSD or BSD?
What's that?
The license?
Yes, it's BSD. All right, thank you.